Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. In today's session, I want to go over the solution of polynomial functions. We already learned how to calculate or how to solve quadratic equations. So we have three ways usually to do it, either by factoring or by completing the squares or by using the quadratic equation. And there are some alterations to that, but mainly it's so easy. Now, what if we are doing a cubic equation or a quartic equation or higher level equations? Sometimes when you go very high, it's not worth doing it manually. You can use a calculator or a computer, but usually for most cubic and quartic functions, we can solve them mathematically using some techniques. So what I want to do today is to go over how we approach a problem so we can make it easier for ourselves. Maybe we can find some gaps where we can jump in and solve. And so I prepared like 4 examples that I will go over and show you what your way of thinking should be. Okay, so let's start with the first one. The first one is a cubic equation. It says x cubed minus 2x squared plus 3x minus 6 equals 0, and we want to solve for x, so we know we have 3 solutions. If you go up over the law of signs meaning S-I-G-N-S, not signs like in trig, like the law of signs when you say A over sign, A equals B over, no, we're talking about the law of signs, okay? We know we have 3 equations. Now, how many of them are positive and how many are negative? Okay, so the law of signs says, look at the change in signs. I have a positive, then negative, so that's one change. Then positive again, that's another change. Then a third change, positive, negative, right? So I have 3 changes. That means we have possibly either, so here we know we don't have negative solutions because, no, maybe we have, we'll see. But when we say 3, it means you have 3 real positive solutions or just 1. You say, why not 2? 3 or 1 doesn't make sense. No, it does perfect sense. Because if you don't have real solution, it must be that you may have 2 imaginary or 2 complex solutions. Why 2 but not 1? Because you always have 2 conjugate answers. If you have a complex solution, then its conjugate is also a solution. Remember, when we solve, and you can see that if the if the quantity under the radical b squared minus 4ac, do you remember what we call that? The discriminant. If the discriminant is less than 0, then you would have 2 answers, some real value plus or minus another value times I. So you cannot have 1 imaginary solution. It has to be either none or 2 or 4 or 6, but always even. So now when it tells me you have 3 answers, 3 positive answers, it may be there are 3 positive answers or 1 positive and 2 complex. But I guarantee there is at least 1 solution that is positive. If you change x into a negative, you will see you get negative x cubed, because negative x to the 3rd power is negative x cubed. Negative x squared is positive x, so you get negative 2x squared as it is. The x becomes negative 3x and negative 6. So all terms are negative, so you can't have a negative solution. So we know that either we have 3 positive real answers or one real answer and two complex answers. Someone will tell me, so is the real solution, you can find it easily? Generally speaking, yes. So I hear someone else would say, so what if it's irrational? I say, no, but no, sir or ma'am. If it's irrational, you get the same thing as the complex. Remember, if you have a square root of 7, for example, as 7 is the quantity under the radical, okay, then you will get plus or minus root 7, something plus or minus root 7. So always come in pairs. So complex answers always come in pairs, and irrational solutions or roots always come in pairs. So definitely we have one real solution. But before saying that, so that's how we check to see if one is, you have a positive or a negative that can be easily found. Because, for example, let's say I found that I have one positive and two negative. I will start with trying the positive, because maybe the two that are negative are both irrational or both complex. So if I have an odd number of roots, it's better to start with that sign. This case is positive. Something else we also need to check. Sometimes you can simplify the problem by checking to see if 1 is a root. I mean, how can a 1 be a root? Very simple. If you add all the coefficients here, I have a 1, minus 2 is negative 1, plus 3 is positive 2, minus 6 is negative 4. So no, we don't have, 1 is not an answer, because if 1 is an answer, you can divide this either by long division or synthetic division by either the factor x minus 1, or by doing synthetic division by 1, and you can reduce that to a quadratic equation that we can solve very easily. Or negative 1. First of all, we know that there are no negative answers, but if we do it, you will get negative x cubed minus 2x squared minus 3x minus 6. Of course, if you add negative numbers, they cannot add up to 0. So we know that won't work. So 1 doesn't work, but what else can work? That's something else you need to check before you start. So this is like the get-go. That's the first thing you check. Is there a 1, a root of 1, or a root of negative 1? If not, the second thing you have to look for is the ratio of the first two coefficients, or the first two terms, I should say, I'm sorry. The first two terms is the same as the third to the fourth? What is that? X cubed divided by negative 2x squared is negative x over 2, right? X cubed over x squared. Notice we don't have these negatives. I just was checking the negative roots. And 3x divided by negative 6 is negative x over 2. If you get this, it means you have to factor out without thinking. And one of the factors would be x minus 2. Someone else would say, can I do something else? Yes, you can. You can check the first and the third and the second and the fourth. If I divide the first by the third, I get x squared divided by 3. And if I divide the second by the fourth, negative by negative is positive. 2 over 6 is 3 in the denominator, and x squared, so x squared over 3. So x squared plus 3 times x minus 2. Now, don't do it like that. Say I'm going to factor the first two terms. I'm going to combine these two terms together and those two terms together. So what do I get? I can factor x squared from here. And that leaves me with x minus 2. Plus, I can factor 3 from here. And that leaves me with x minus 2. X minus 2 and x minus 2, I factor them out. So I get x minus 2 times x squared x minus 2 plus 3 equals 0. And as we expected, x equals 2 is an answer. X squared plus 3 is 0, meaning x squared equals negative 3, or x equals plus or minus 3i. And these are the three answers. So I check to see if 1 is a root. No. Negative 1? No. Is the ratio the same? Yes. So factor. Okay? So that's the first thing we do. Later, I will tell you something that is not like theoretical. It's something you can attribute it to me. I will tell you about them later. Remember, I told you once when we were working with quadratic equations that when I was your age, we didn't have calculators. And remember when I told you I always use x as 10 because it made my life easy. If I see x cubed, that's 1,000. I don't need a calculator to multiply. X squared is 100. So we see how can that help sometimes. Turn the page. Second example. Okay, let's look at this example. X cubed over that, you get x over negative or negative x over 8. No. So I cannot factor. Right off the bat, I decided not to factor. Is 1 a solution? 1 and 11, 12, 32, and negative 8. No, it cannot be. How about negative 1? Well, if I make this negative, so with the different color, I'm going to add the negative. And this would become negative because if x is negative, this would stay because if x is negative 1, negative 1 square is positive 1 times negative 8. It's still negative 8. Now let's add the coefficient. Negative 1, negative 8, that's negative 9, minus 11, that's negative 20, plus 20. Bingo! X equals negative 1, meaning I have a factor x plus 1. Then you divide. It's up to you. You can divide using long division or synthetic division. Of course, synthetic division is much easier using Horner's law. You can write the coefficients, the original one, okay? 1, negative 8, 11, and 20. And you check, don't check. We know that x equals negative 1 is a solution, so you write negative 1. You bring down the 1, and then you multiply. 1 times negative 1 is negative 1. Add them up, you get negative 9. Negative 9 times negative 1 is positive 9. Plus 11 is 20. 20 times negative 1 is negative 20. Plus 20 is 0. So that is correct. The second bracket will have, notice this was x cubed. We reduce the power by 1. So we get x squared minus 9x plus 20 equals 0. We can factor the second. We have two values that their product is 20 and their sum is negative 9. That's negative, of course, negative 5 and negative 4. So we have the three roots right there, negative 1, or x equals 5, or x equals 4. It helped when we knew ahead of time that 1 or negative 1 is an answer. That's the second example. Let's move to the third example. The third example is easy. It's a quartic, but it's easy. Why is it easy? Because that can be solved as a quadratic equation. What? Quadratic? How? 4 to 0. So instead of x squared, we have x to the 4. Instead of x, we have x squared. If it's not clear to you, say for any variable, let's say let u equals x squared. So let's rewrite that. If u is x squared, then x to the 4 is u squared. X squared is u plus 45 equals 0. Then you would say, okay, u minus 5 times u minus 9, right? They add up to negative 14. They multiply to 45. So u equals 5 or u equals 9. You replace back and you say x squared equals 5, hence x equals plus or minus root 5. X squared equals 9, so x equals plus or minus 3. And here are the 4 roots very easily. That was an easy one. The last one is the trickiest one, okay? The last one, if you try to factor, this over that is 1, but this over that is 5/12, so, or 7/12, I'm sorry. They are not the same. Check 1, of course no. 2 minus 24 minus 14 is not. Even if you switch, that would be -1, and that would be positive 14. So you get -1 and positive 1 cancel, and 14 minus 24 is not 0. So 1 is not an answer root, -1 is not a root. I cannot factor. What is the only way I can do it? How? What is the only way you can do that? First of all, notice there is one sign change, meaning there is one root that is positive, meaning 2 are negatives or 2 are complex. So definitely I will check the positives only. However, the polynomial rule that tells you if there are real roots, there must be plus or minus all the factors of the free term divided by the factors of the leading coefficient. The leading coefficient is 1, so you cannot factor that. But the 24, oh my God, it's 1 or 2 or 3 or 4 or 6 or 8 or 12. A lot of them. But the good thing is I don't have to worry about the negative. I know definitely one of them is positive. My suggestion is you always try to pick something in the middle, a 4, a 6, something. So let's say we pick the 6. We think 6 may work. So I will do the synthetic division, and I will say 1, 1, -14, -24. I picked 6. I bring down the 1 times 6 is 6, plus 1 is 7, times 6 is 42, minus 14 is 28, times 6 is 168. So that's positive, right? 144. You stop right there and you say, wait a second. If you are checking a positive root and you get all positive remainders, it means 6 is an upper limit. If 6 didn't work, then 8 will definitely not work and 12 will definitely not work. We also excluded 1. So now the problem became much easier. I can go one by one. 6 didn't work. I can start or try the 4. 1, 1, -14, -24, bring down the 1, times 4 is 4, plus 1 is 5, times 4 is 20, minus 16 is 6, times 4 is 24, minus 24 is 0. Bingo! I have x minus 4 is a coefficient because x equals 4. So must be that x minus 4 is a coefficient. And the second one is x squared. Remember, we had a cube. We reduce the power, so it becomes x squared plus 5x plus 6 equals 0. You need two values that multiply to 6 and add to 5. Definitely they are 2 and 3. So you have x minus 4 times x minus 2, plus 2, I'm sorry, times x plus 3 equals 0. So x equals 4, or x equals -2, or x equals -3. And these are the 3 roots. And that's the last example. Earlier, I told you I had my own method of either checking or finding the roots in a weird way. You might like it, then you can use it. If you don't like it, then just ignore it, okay? That's not really math. It's just an easy way. What I used to do is to say, okay, this is x cubed. So I'm going to assume every time for all these four examples, I'm going to assume x is 10. So x cubed is 1,000 minus 2 times x squared. X squared is 100, so minus 200. That's 800 now. Plus 30, 3 times x, which is 3 times 10. Plus 30, so that's 830. Minus 6 is 824. Good enough? Okay, so let's now find the prime factors of that. I'm going to divide it by 2. I get 412. Divided by 2 again, I get 206. Divide by 2 again, I get 103, which is a prime number. I'm stuck. But the 103 tells me something. It has to be x squared plus 3, right? You cannot factor it into something like 10 times 11 or 9 times 12, something around the 10, two numbers. It's prime. 103, definitely one of my factors are x2 plus 3. And even, you know that, so we have 103 and we have 8. 2 times 2 times 2, right? It has to be 8. But what is 8? 8 is 10 minus 2. Notice everything is attributed to 10 or 100. 8, so 8 has to be 10 minus 2 or x minus 2. In fact, now it's easy to see that since the free term is -6 and you have a 3, then this has to be -2, nothing else. And I solved it very quickly. Or if I already solved the problem, I can check to see if that's what I got by just prime factoring. See that? I hope you like it. If you don't, as I said, just you can stop the video here and ignore the rest. Number 2, I have x cubed, that's 1,000. Minus 8 times 100, minus 800, that's 200. Plus 11 times 10, so plus 110, that's 310 now. Plus 20, that's 330. Okay. Take the prime factors, divide by 2, you get 165. This is divisible by 3. Divide by 3, you get 55. Divide by 5, you get 11. Divide by 11, you get 0. 11 is x plus 1. There is nothing else, right? So x plus 1. Then someone would say, so, okay, so is the second one 5 and 6 or 10 and 3 or 15 and 2? How do I know? Well, notice that 5 and 6 make sense. Why? Because 6 is x minus 4 and 5 is x minus 5, and -4 times -5 is positive 20. Times 1 is positive 20. But if I pick, say, for example, 5 and 6, I'm sorry, if I pick 10 and 3, 10 would be just x, which is impossible. I cannot factor x here, so I can exclude that. So you can quickly find out that, or worst case scenario, now if you know that x equals -1, use synthetic division and find the rest because it's a quadratic equation. But it's easier to see it's x minus 4 times x minus 5 because of the positive 20. So very small, trial and error, not even trial and error, but very simple trial and error would give you that. That's the second one. Let's go to the third one. The third one didn't need work because that was that's basically was we have irrational answers. But if you want to do it, I would, this is easy because it's quadratic equation, but let's say you didn't realize that it could be solved as that. You would get 10,000, 100, so minus 1,400 plus 45. If you subtract here, you get 8,600, right? Plus 45, so it's 8645. This number is divisible by 3 and it's divisible by 5, right? Why? Because it ends with 5. And if you add the digits, you get 4. No, I'm sorry. It's not. I said divisible by 3. That's not divisible by 3. It's divisible by 5. So if I divide by 5, what do I get? I get 1, 7, 2, right? 17 will give me 85, and then 14 will give me 2, and then I get 9. 1729. How come it's not divisible? Shouldn't that be? Oh, no. Okay. So once you get here, do you see this number? Do you know what is divisible by? Anybody knows? I gave you this before. I told you usually we check. Of course we ignore the 2. The number is odd to begin with. They don't add up to 3 or multiples of 3, so it's not divisible by 3. It doesn't end with 0 and 5, so it's not 5. How about the 7? We check the 7. Remember, I told you that in a previous video. I say for divisibility, just keep the unit digit by itself and the rest by themselves. Double the unit digit and then subtract it from the rest. 172 minus 18 is 154. 154 is 22 times 7. But if you don't know that, you repeat it. You say 15 and 4. You double the 4 and subtract it from the 15. You get 7, so it's divisible by 7. So I'm going to divide by 7. And when I divide by 7, I get 2. 32 is 4. 49 is 7. You get 247. Okay? 247. What is this divisible by? It turns out that it's divisible by, for example, 13. I didn't show you something else. Maybe I'll keep it for another day, but it's also divisible by 19. No, I don't want to go there for now. I can give you another session where I show you how easy you can check for divisibility of 19. Very similar to the 7, but adding instead of subtracting. Anyway, so I'm going to divide by 13, and I'm going to get 24 divided by 13 is 1, and the remainder is 11. You get 117. 117 divided by 13 is 9. And then finally, you divide by 19. Okay, now we have a problem. I have a 5, right? It turns out that 5 is not one of the answers. X minus 5 is not an answer. 7 is x minus 3, and 13 is x plus 3. That's basically these two roots. And this one, as I said, it was much easier to do it as a quadratic equation. So really, it's not easy for this example to use this method. I told you, most of the time it works, but sometimes it's very hard. If you recognize those, then you can use the synthetic division with 3 and negative 3, and that would reduce it to a quadratic equation that would solve for the plus or minus root 5. Okay. So it didn't work quite well for this one. Let's move to the last one. 1000 plus 100 minus 140, so that's 960, minus, so 100 minus 140 is negative 40. 1000 minus 40 is 960. 960 minus 24 is 936. Divide by 2, you get 468, right? Divide by 2 again, you get 2, 3, 4. Notice it's divisible by 3 and 9, by 3 twice. Divide by 2 again, you get 117. Divide by 3, you get 39. Divide by 3, you get 13. Divide by 13, you get 1. Nice. 13 is the easiest one because here I don't know, is that 9 or 6 or 4 or 12? There are many differences, right? But I know that this has to be, if it's x plus 3 would give me 13, meaning x equals negative 3 is one of the solutions. But one of the factors is x plus 3 because I have 13. X plus 3, and I have negative 24. So the other two factors, when I multiply them, they should give me negative 8. So how do you do that? I can say 9 and 8, for example, but 9 and 8 is x minus 1 and x minus 2. So I will get like positive 6, not negative 24. So I have to make something different. And you can try back and forth. Eventually, you have to find that you get 2 times 2 times 3, which is 12, because that would be x plus 2. And 2 times 3 is 6, which is x minus 4. And now we multiply negative 4 by positive 2 is negative 8 times 3 is negative 24. Again, as I said, if that's hard, you already found that x equals negative 3. So go and do a synthetic division at that stage. Instead of checking, where do I start? Is the 4 works? Does the 6 work? No, you can easily, the 13 here definitely is telling you x plus 3. There's nothing else. You cannot have, for example, 2x because x cubed has a coefficient of 1. So we don't have 2x minus 7, for example, to give me 13. It has to be, one of the answers is negative 3. 1, 1, negative 14, negative 24. Bring the 1 times negative 3. Add them up times negative 3. Add them up times negative 3, 0. So you get x plus 3 times x squared minus 2x minus 8 equals 0. I need two numbers that multiply to negative 8 and add up to negative 2. So definitely they are x minus 4 and x plus 2. And you get the same result. 4, negative 2, negative 3, easy. So it gives you the first step. It gives you one of the two solutions, one of the three solutions. Synthetic division reduces that to a quadratic equation, and the rest is history. I hope this wasn't too long for you, and hopefully it's helpful. As I said, if this approach doesn't suit you, or if you think it's like, why would I go through this? It's fine. It's most important to understand that you need to try to see if you can factor. If not, is 1 a solution? If not, is negative 1 a solution? These 3 steps can simplify a lot of problems. If not, then you use this approach. If you see that positive and negative, one of them has odd roots, start with it. Don't start with the double, because they may be either complex or irrational. But if you have an odd, then you definitely have one real solution, positive or negative. It doesn't matter. It depends on which one is odd. I mentioned something. I said, when you do, when you do the synthetic division with a number in the middle and you get all of these numbers or all of these remainders positive, 6 becomes an upper limit. So don't check the 8 or the 12. That would be a waste of your time. What if I was checking the negative root and then I get numbers, or these numbers were alternating, positive, negative, positive, negative, positive, negative? That's an indication that what you have here is a lower limit. If there is an answer, it would be more than that. Okay? Does that make sense? Let me tell you something. This was 24. So I could have had like instead of -3, I may have -4 or -6 or -8. So let's pick a number like -8, for example. Suppose I started with -8. I'm sorry if I'm wasting your time, but this might be important. 1, which is positive, times -8 is -8 plus 1 is -7, which is negative. You get 56. 56 minus 14 is 42, which is positive. Times -8 is -336. Add that, you get -360, which is negative. Positive, negative, positive, negative says there is nothing less than -8. Notice -12 is less than -8. So you can exclude both -8 and -12 and try -6. You will get also positive, negative, positive, negative. So you cross it and maybe you would say, okay, let me jump to -3. You will stumble on that. But these two things are sometimes also gives you a guideline. If you are checking a positive root and all the remainders are positive, then don't check anything higher than that. If you were checking a negative root and you get an alternating positive, negative, don't check anything below that, like -12. Notice -12 is less than -8, so don't check it. Check something higher until you get the -3. Okay? Again, I hope this was helpful. If you have any comments, please leave them in the comment section and I will get back to you as soon as I can. Otherwise, have a great day and I hope to see you soon.